We will start with the third type of variable head meter, which is Pitot tube. Basically, Pitot tube sends two pressures simultaneously, impact pressure and static pressure. So in Pitot tube, we can simultaneously measure two pressure, impact pressure and static pressure. The impact unit consists of a tube with one end bent at right angle towards the flow direction. You can see in the sketch, this one end of this flow meter, see here, this one end of the flow meter is deep into the flow area and it is bent at an angle towards the flow direction. So, the Pitot tube basically consists of a tube with one end bent at right angles towards the flow direction. We can easily understand from the figure. This is the flow direction and the tube inserted like this. And this tube sensing a various velocity pressures across the pipe, which are then averaged within the tube assembly to give a representative flow rate of whole cross section. So what will happen? Here, see, the flow is in this direction, you can see, this is my Pitot tube. As flow is going in this direction, here there is a tube. So what will happen? The fluid tries to go inside this tube, and depending on the velocity of this fluid, the fluid is rising in the tube. So, and in this another side, see, in this side we have attached U-tube manometer. So what will happen? According to the velocity of this fluid, the fluid rising in this tube, tube. So according to that pressure, you can see the pressure difference in this U-tube manometer. See this blue portion in the U-tube manometer. Now this pressure difference varies according to what? According to the velocity of the fluid which is flowing inside the pipeline. And according to that, the velocity and the pressure difference you can easily measure from U-tube manometer. So the tube sends various velocity pressures across the pipe and which are then averaged within the tube assembly, and that will give a flow rate of this whole cross section. So the construction of the Pitot tube is very simple. It just consists of a tube which is bent at the one end, and that bent part is inserted in the pipeline where the fluid is flowing. So it is very simple in construction. Now let us discuss about the advantages and disadvantages of using this Pitot tube. Advantages of this Pitot tube: it is very small and do not contain any moving part. As I already told you, Pitot tube is nothing but a simple tube which is bent at one angle. So there are no moving parts, and that's why it is very simple in construction. Low permanent pressure drop. In Pitot tube, there are no, or I can say there are low pressure loss. So it is very, I can say it is one of the main advantage of using Pitot tube. It is cost low. The cost of the Pitot tube is very low as it includes no moving parts. The construction of the Pitot tube is very simple. So the cost of the Pitot tube is low and easy to install. Right. So these are the advantages of the Pitot tube. Simple in construction, low cost, contains no moving parts and easy to install. Let us discuss the disadvantages of the Pitot tube. The biggest disadvantage of using Pitot tube is low accuracy. The accuracy of this Pitot tube is very low, as well as low rangeability. The range of measuring the flow rate of a fluid by using this Pitot tube is low. So, when we want high accuracy reading or we want a wide range ability, we cannot go for the Pitot tube. Then we have to choose another types of variable head meters, which are orifice and venturi. Another disadvantage is foreign material in a fluid can easily clog the Pitot tube. Or I can say the fluid which contains the solid material or the foreign material, then it damages the Pitot tube or it plugs or clogs the Pitot tube. So, in application where the fluid contains foreign material or where the fluid contains solid material, we cannot use the Pitot tube. At that time, we have to use the venturi or orifice meter. So, the disadvantage of Pitot tube includes low accuracy, low rangeability, and with foreign materials, we cannot go for the Pitot tube. So, these are the advantages and disadvantages of using Pitot. Now, let us discuss about the flow equation of Pitot tube. See the figure. The main pipeline where the fluid is flowing, we have inserted a Pitot tube. See in figure point 1 and point 2. At point 1 and point 12, we have installed U-tube manometer. If you have marked that in all types of flow meter, we have installed U-tube manometer where there is a pressure difference. In this Pitot tube, you can see at point 1 and 2, there is a pressure difference where the fluid enters the tube at point number 2. So, there is a pressure difference between point 1 and point 2, and that's why we have installed U-tube manometer, or I can say that the ends of the U-tube manometer, 1 and 2, ends of the U-tube manometer is installed where there is a pressure difference. Fine. So, see, here we have installed this U-tube manometer at point 1 and 2. In the same way as we have done in orifice meter and venturi meter, we have to apply the Bernoulli's equation at point 1 and point 2. So, by writing the Bernoulli's equation between point 1 and 2, I can write the equation as P1 by rho plus U square by 2 is equals to P2 by rho. Now, there is a question arise in our mind that why we have not written the velocity term at point 2. Z1 and Z2 obviously we have not written because there is a horizontal pipeline. So, we have not written Z1 and Z2 term because it is cancelled out. But a question arises that why we have not written the velocity term at point 2. Because at point 2, the velocity is very less as compared to point 1. And that's why we are neglecting velocity term at point 2. And we have written this Bernoulli's equation at station 1 and 2 like this. P1 by rho plus U square by 2 is equals to P2 by rho. Writing Bernoulli's equation is very important. Now what will happen? After rearranging this equation for velocity, from previous equation, I am just rearranging the equation because I want equation for velocity. So what will happen? U is equals to 2 times P1 minus P2 upon rho whole raised to 1 by 2. Right? Now, we are installing or we are using YouTube manometer. I can write the P1 minus P2 is equals to delta H rho m minus rho into G for YouTube manometer, that we all know very well. So, in P1 minus P2, in place of P1 minus P2, I can write delta H rho m minus rho into G. So, now my equation for velocity will be U is equals to 2 delta H rho m minus rho into G divided by rho whole raised to 1 by 2. Now, this delta H rho m minus rho into G divided by rho, for that whole I can write capital delta H. Now, what is this capital delta H? Capital delta H is pressure head. We all know very well about head, which is expressed in terms of meter of flowing fluid. So, if delta H is pressure head expressed in terms of meter of flowing fluid, then delta H is equals to, capital delta H is equal to small delta H rho m minus rho upon rho. See this, capital delta H is small delta H rho m minus rho upon rho. So, this whole term will be replaced by capital delta H. So, now I can write that small u is equals to under root 2g capital delta H. Understand what I have done? In this u equation, 2 is as it is, this small delta H rho m minus rho upon rho, this whole term is replaced with capital delta H. So, the equation of now velocity becomes u is equals to under root of 2g capital delta H. This capital delta H is a pressure head which is expressed in terms of meter of flowing fluid. But this velocity is equation by considering that there is no friction loss, but the friction is always exist. So, again I have to introduce the correction factor for Pitot tube. In similar way, we have introduced in case of orifice and venturimeter. So, see, by taking into consideration loss of energy due to friction, we have to introduce a correction factor for Pitot tube, which is capital C. So, in U equation, U is equals to capital C, which is correction factor for Pitot tube, under root 2g capital delta H. Now, if I have the equation of velocity, I can easily calculate flow rate. Capital Q, which is volumetric flow rate, Q is equals to U into A. U is this C under root 2G delta H. So, by using this equation, I can easily calculate the flow rate of the fluid flowing through Pitot tube. So, this is the flow equation of Pitot tube, or the equation for calculating the flow rate. So, in today's session, we have covered Pitot tube along with its construction and working, advantages and disadvantages, as well as flow equation of Pitot. So, till now, we have covered all types of the variable head meter. In that, we have seen orifice meter, venturimeter and Pitot tube along with its flow equation. So, now in our next session we will see about the second type of the flow meter, which was the variable area meter. I hope this is clear to all. Thank you.